Hi everyone, welcome back to Technical Mathematics lectures conducted by Vadhyar Online Academy. In this video, we will continue with the topic derivative of a function. And in particular, we will discuss chain rule and implicit differentiation. So let's get started. At first, let's discuss about chain rule. If the given function is in the form y equal to f of g of x, then dy by dx, that is derivative of y, will be equal to f dash of g of x into g dash of x. So here function f is the outside function, and function g is the inside function. Okay, so the derivative of y will be equal to derivative of f into derivative of g. Okay, let's see few examples to make this point clear. Let's see problem number 1. Find derivative of the function f of x equal to sine square x. So in this case, the function f of x is given as sine square x. Let's rewrite that. We may write it as sin x the whole square. Okay, now in this case it is in the form f of g of x. Okay, f represents the outside function and g represents the inside function. By looking into this expression, we may distinguish both outside and inside functions. Outside function f will be the square function and inside function g will be sin x. Okay, so derivative of the function will be f dash of g of x into g dash of x. Okay, so we know that if f of x is equal to x square, then its derivative f dash of x will be 2 into x. Okay, now in place of x we have g of x here. Okay, so therefore f dash of g of x will be 2 into g of x. G of x is sin x here, so we get it as 2 into sin x, that into g dash of x, that is derivative of g of x. Since g of x is sin x, its derivative g dash of x will be nothing but cos x. Okay, so we get the answer as 2 into sin x into cos x. Okay, or we may write it as sin 2x. Okay, let's see another problem. Find derivative of the function f of x equal to e raised to cos x. So we are given a function which is in the form f of g of x. So f represents the outside function and g represents the inside function. In this case, outside function will be the exponential function e raised to something, and the inside function g is cos x. Okay, so derivative will be f dash of g of x into g dash of x. As per chain rule, this will be the derivative. Okay, now we know that if f of x is equal to e raised to x, then f dash of x will be e raised to x itself. Okay, so when you find out f dash of g of x, we will get it as e raised to cos x itself. Okay, then that into g dash of x. G dash of x is derivative of the function g. G is nothing but cos x, therefore derivative of cos x is minus sin x. Okay, so answer is minus of e raised to cos x into sin x. Okay, let's see another problem. Find derivative of the function f of x equal to 1 minus 2x whole cube. So here this function is also in the form f of g of x. Okay, so outside function f is the cubic function and inside function g is 1 minus 2x. Okay, so as per chain rule, the derivative will be f dash of g of x into g dash of x. Okay, Now we know that if f of x is equal to x cube, then the derivative f dash of x will be 3 into x raised to 3 minus 1, that is 2. Okay, so in this case f dash of g of x will be 3 into 1 minus 2x whole square. Okay, that into g dash of x, that is derivative of g of x, will be derivative of 1 minus 2x, that is minus 2. Okay, so here the answer will be 3 into minus 2, that is minus 6 into 1 minus 2x whole square. Okay, now let's move on to the next topic, that is implicit differentiation. So in some cases the function could be given as an implicit one. For example, find dy by dx if x square plus y square is equal to 9. Okay, so in this case what we have to do is we have to differentiate both left hand side and right hand side with respect to x, and we have to find out dy by dx. So when you differentiate the first term, that is x square, we will get it as 2x, and when you differentiate the second term, that is y square, you will get it as 2y into dy by dx, and when you differentiate the term on right hand side, we will get 0 because it's a constant. Okay, now by modifying this expression, what we get here, we can obtain the expression of dy by dx, and we will get dy by dx as minus x by y. Okay, so this is how we do implicit differentiation. Okay, let's see one problem. Find dy by dx if x into y is equal to sine y. Okay, so as per implicit differentiation, we have to differentiate both left hand side and right hand side of this expression. So when you differentiate the left hand side, what we get is x into dy by dx plus y into dy dx of x, so that will be 1. So we get the differentiated version of left hand side as x into dy by dx plus y. That should be equal to the differentiated version of the right hand side. So when you differentiate the right hand side, what we get is cos y into dy by dx. Okay, now let's combine the terms which have dy by dx. So what we get is x minus cos y into dy by dx plus y equal to 0. Okay, now let's rearrange this expression and try to find out dy by dx. So when you do that, we will get dy by dx as minus y divided by x minus cos y. Okay, so by making use of implicit differentiation, we can find out the value of or the expression of dy by dx. Now let's discuss one previous year exam question. Derivative of cos inverse of sin x with respect to x is. So we are asked to find out derivative of cos inverse of sin x. Okay, so you may try to solve this by yourself. Please pause the video and try to solve this question. Okay, I hope you have solved the question. Here the right answer is given by option D, that is minus 1. Okay, let's see how to solve this. Here this function is in the form f of g of x. Okay, here outside function f is the inverse cosine function and the inside function g is sin x. Okay, so derivative of this function as per chain rule will be f dash of g of x into g dash of x. Okay, now we know that if f of x is equal to cos inverse of x, then f dash of x will be minus 1 divided by root over 1 minus x squared. Okay, so in place of x, what we have is sin x. Okay, so f dash of g of x will be minus 1 divided by root over 1 minus sin square x. Okay, now that into g dash of x. G of x is sin x here, so g dash of x will be cos x. Cos x. Okay, so let's simplify this. Minus 1 divided by root over 1 minus sin square x. It is nothing but cos square x. Okay, that into cos x. Okay, so we will get it as minus cos x divided by root over cos square x is cos x. Okay, so we get the expression as minus cos x divided by cos x. So we get the answer as minus 1, and this answer is given by option D here. So option D is the correct answer. Okay. Now let's see another problem. The derivative of log root x with respect to x is. So we are asked to find out derivative of log root x. So you may try to solve this by yourself. Please pause the video and try to solve this. Okay. Now here the right answer is given by option B. The right answer is 1 by 2x. Let's see how to solve this. You can see that this function is in the form f of g of x. The outside function f is nothing but the logarithmic function, and the inside function g is root x. Okay. Now as per chain rule, the derivative of this function will be f dash of g of x into g dash of x. Okay. Now we know that if f of x is equal to log x, then its derivative f dash of x will be equal to 1 by x. Okay. Now in this case, in place of x we have a root x. Therefore f dash of g of x will be 1 by root x. Okay. That into g dash of x. G dash of x is derivative of g of x, and g of x in this case it is root x. Okay, so therefore derivative of root x will be 1 by 2 root x. Okay, so the derivative of the given function will be equal to 1 divided by 2 into root x, that is x. So answer is 1 by 2x. Okay. So with this we are coming to end of lecture 22. In lecture 23 we will continue with calculus. We will discuss about integration. Okay, so see you in lecture 23. Goodbye.